Now that we know how to find several pieces of information about the graph of a parabola algebraically, we can use that information to do things like graphing the function. Here's an example where we're going to sketch the graph of a given quadratic function, and we're asked to, on that graph, label the x-intercepts, the y-intercepts, and the vertex. What we're actually going to do is calculate those quantities first, so that if we're drawing this graph by hand, we can then just draw the appropriate curved shape that goes through all of those points. Let's start by finding the intercepts. To get a y-intercept, plug in a 0 for x. So all you have to do is replace the x's with zeros and simplify. The result is -7, so that's the y-intercept. That's where this graph crosses the y-axis. Similarly, to get x-intercepts, plug in a 0 for y. So this is a general idea from algebra. To get an intercept, you plug in a 0 for the other thing. And in this case, it's the output of the function, right? When we graph this, it's like we're saying y equals this function. And so if I plug a 0 in for y, I get this equation. And that's a quadratic equation I can solve. There are several ways to solve it. I could use the quadratic formula, but with these coefficients, it turns out to be easy enough to solve it by factoring. 7 and -1, those add together to give you +6. 7 and -1 multiply together to give you -7. So we can factor like this, and then it's immediate how we get the x values that solve the equation from there. Either the first factor is 0 or the second factor is 0. So either x is -7 or x is +1. Those are the two values where this graph crosses the x-axis. So again, from this function, we're going to find the vertex. Here's our vertex formula. Numerator is b, denominator is 2a. b and a is 1. Plugging those values in to -b over 2a and simplifying gives us -3. So that's the x-coordinate of the vertex. To get the y-coordinate of the vertex, we just plug that back into the original function. So we get -3x squared plus 6 times -3 minus 7. And when you simplify that, it comes out to -16. So that means, from the previous screen, we have the x and y intercepts, -7 and 1 for x, -7 for y. And then the vertex we found here, its x and y values. So this represents the coordinates of that vertex point. So now let's look at a graph. Here's a computer-generated graph, which we're going to label. If you were going to draw this graph by hand, you'd start by labeling the points. So I draw a point at -7 and at 1 on the x-axis, because those are the x-intercepts we found. I draw a point at -7 on the y-axis, because that's the y-intercept we found. And then I'd draw a point at -3, -16, because that's the coordinate we found for the vertex. So if we're labeling these, we could write the vertex is at -3, -16. And then my intercepts are at x equals -7, x equals 1, and y equals -7.